Welcome back to part 5 of our DIY autonomous mobile robot building series. If you missed any of parts 1, 2, 3 or 4, catch up with the links in the video description below or access the link to the playlist at the end of this video. In part 4 we connected up all the components to the circuit board. Now we are ready for the operational testing phase. We'll need to open the Arduino IDE to get started. We'll also need to connect the Arduino to a laptop or a PC. Here's the Arduino code for testing each component. Please also check out the link in the description for a copy of this code. We have 3 servo objects: left servo, right servo, and SG90 servo. Pin assignments are defined for each servo. Left servo pin is set to analog pin 10, right servo pin is set to analog pin 9, and SG90 servo pin is set to digital pin 11. There's no real need to create an object for the HCSR04 ultrasonic sensor, so we'll just need to define pin assignments: trig pin to digital pin 4 and echo pin to digital pin 7. We have a number of variables initialized here, mostly self-explanatory. However, I will mention that the variable servo value offset, which is set to 90, is necessary for the left and right modified servos because sending the value 90 initializes each of these servos to the neutral position or the stationary position. To learn more about testing the modified Hi-Tech 311 servos, check out the link to testing a modified servo with Arduino at the end of this video. Serial communication is initiated at a baud rate of 9600 and the servo objects left servo, right servo and SG90 servo are attached to their respective pins, which are defined above. Pin modes are set for trig pin, which is the output of the ultrasonic sensor, and echo pin, which is the input. The loop function continuously runs and checks for input from the serial monitor. If the L key is pressed, the serial monitor indicates testing the left servo and calls the function test servo for left servo. The operation of the left servo is tested accordingly. If the R key is pressed, the serial monitor indicates testing the right servo and calls the function test servo for right servo. If the S key is pressed, the serial monitor indicates testing SG90 servo and calls the function test SG90 servo for the object SG90 servo. If the U key is pressed, the serial monitor indicates testing the HCSR04 ultrasonic sensor and calls the function test ultrasonic sensor with the parameters trig pin and echo pin. The function test servo has 3 loops. A first loop to gradually change the servo speed from stationary, start, to the maximum clockwise speed, upper limit. A second loop to gradually change the servo speed from the maximum clockwise speed, upper limit, down to a stop, and then gradually to a maximum counterclockwise speed, lower limit. And then a third loop to gradually change the servo speed from the maximum counterclockwise speed, lower limit, back to stationary, start. The function test SG90 servo tests the SG90 micro servo by gradually changing its position from 0 to 180 degrees and back. The function test ultrasonic sensor prompts the user to place an object in front of the HCSR04 sensor and then to press U again when ready. Then the function test ultrasonic sensor initiates a distance measurement using the ultrasonic sensor and displays a measured distance in the serial monitor in centimeters. The function sends a short pulse to the ultrasonic sensor by setting the trigger pin to low, waiting for a very short duration of 2 microseconds, setting the trigger pin to high, waiting for 10 microseconds, and then setting the trigger pin to low again. In other words, a 10 microsecond pulse is sent to the trigger pin, which is the recommended length of pulse. After that, the function uses pulse in to measure the duration of the pulse received at the echo pin. And then the distance in centimeters is calculated using the formula distance equals duration times 0.0343 divided by 2. The factor 0.0343 represents the speed of sound in air in centimeters per microsecond, and dividing by 2 accounts for the round-trip distance. So let's compile and run this code and see what happens. I'll just speed up the camera for the compiling. Make sure you remember to switch on your battery pack before you start testing the various components. Open up the serial monitor and input L to test the left servo. And the left servo starts rotating clockwise, steps up in speed until it reaches a maximum rotational speed, and then steps down in speed until the servo stops. Now the left servo has begun rotating in the counterclockwise direction, stepping up in speed until it reaches a maximum rotational speed. Thereafter, the left servo steps down until the servo stops. So that's the left servo tested, and there doesn't seem to be any problems with the circuit so far. Next, we'll test the right servo by inputting R in the serial monitor, and now the right servo starts to rotate clockwise while increasing its speed, then steps back down to the stop position, and then rotates counterclockwise, increasing its speed, and then decreasing its speed down to 0 again. Next, we'll test the SG90 microservo by inputting S in the serial monitor, and there we have the SG90 rotating its servo horn. The horn is rotating rather slowly because I used a delay time of 1 second. The horn is rotating from one extremity to the other and back again. I might just speed up the camera here. Lastly, we'll test to see if the ultrasonic sensor can measure distances from this box I have here. So we'll input U, and then we'll input U once again when we're ready to measure the distance from the ultrasonic sensor to the box. As you can see, we have measured a distance of 4 centimeters, which seems about right. So let's also try a longer distance. Input U, and then U again when we're ready to measure, and we get a distance of 18 centimeters. So, success across all components. This means that the circuit has been designed correctly and also built correctly, and marks a major milestone in our project. Click here for part 6, where we will start designing the chassis for our robot using Fusion 360. If the link for part 6 is not shown, this means that part 6 is not ready for uploading. Please check the description below for my uploading schedule. Thank you so much for watching.